moving on to the next section of our question. So we have question B, calculate the total power output of a kiln when the elements are in delta configuration. So previously we have calculated our I line equals 38.99 amps. So our power formula is relatively simple. Power equals √3 times V line times I line. This is times cos theta, because our connection is resistive elements. Cos theta equals 1. Our I line is 38.99. Our V line, we've been told, is 400, and our √3 is just √3. So we have power equals, and now we can put this in our calculator. I've already got my 38.988 in there, so I'm not going to rewrite it. Doesn't matter on order of operation, so we'll go times by 400, times by square root of 3, and we get power equals 27011.817, so 82 watts. So we look at our answer sheet here. So they have power equals √3 times I line times V line times power factor, √3 times 39. They've obviously rounded up the extra 0.01 of an amp. Not a big deal, times by 400, and so they get 27,019.2 watts. We got 27,011.82 watts. We're actually more accurate than them because they have rounded. The next one we have is what size fuse will we need? The minimum size fuse. So we have 40 amps, being that it's a 39 amp cable. That is the minimum size that could handle the continuous current of the furnace. And our next question is, what is the power difference if it's ran in star? So if it's ran in star, our formula is quite simple. This is the power star. I'll do power delta, I think. Delta equals 3 power star. So all we have to do is get our 27,011, divide that by 3, and we get the power of star. So P star equals 9003.94. Because it's 0.939, it rounds up. Now, the trick in this question that caught a lot of people is, if you actually look, they ask, calculate the difference in power output of the kiln if the elements were connected in star. They want the difference, not the power output in star. So now we actually have to get 2 times that, which gives us 18007.88. And the reason why I multiplied that by 2 is we essentially divided by 3 to get here. So it is the total power output of our delta. So divided by 2 equals times by 3 equals. So it works out to be 27011.82 minus our 9003.94. However, I've obviously done that without doing the rounding in the first place, which gave us our 18,007.88 watts. We have a look at theirs. They have 18,078.87 watts. They have rounded. That is why they're less accurate. Thing to remember in the final exam is you have a tolerance. I believe it's up to 5% for this reason, because we are starting to become electricians, not mathematicians. I prefer to not round in my answers until I get to the end, because it gives you the more accurate result. However, that is not required if you need to write stuff in the middle because you are not so experienced with the calculator. That is absolutely fine.